Now that we've described the structure, functionality, and key methods of the Java cyclic barrier, let's go ahead and take a look at an example application. This application will show how to program with Java cyclic barrier in practice. The app we're going to use is a variant of the Android app we talked about for the countdown latch implementation, except this version uses cyclic barrier objects to coordinate the concurrent benchmarking of 4 greatest common divisor, or GCD algorithms. Recall again that GCD computes the largest positive integer that's a divisor of 2 numbers. For example, the GCD of 8 and 12 is 4. 4 algorithms are tested in this app. First, the GCD method defined by big integer is used. Second, an iterative Euclid algorithm. Third, a recursive Euclid algorithm. And finally, a more complex GCD algorithm that uses binary arithmetic. And as you can see on the right-hand side of the screen, as the algorithms are running, 1 per thread on my quad-core simulator, you're able to see which algorithm is running most efficiently at any given point in time. The details of these algorithms are not important for our discussion, so we won't focus on them. However, you can take a look at the source code to see how they work. Let's start by taking a look at the GCDCyclicBarrier Test Class walkthrough. This test is actually a unit test that runs within the Android Studio project that creates 4 worker threads that use exit and entry barrier cyclic barrier objects. The makeGCDTuples method initializes all the GCD algorithms. We then go ahead and create an entry barrier, which in this case is a cyclic barrier that's sized for the number of algorithms plus 1 for the test thread that initializes all the other tests. We give a barrier action to our cyclic barrier for the entry barrier, which will reallocate the input for each cycle that will be running for the test. We then go ahead and create an exit barrier. This is also a cyclic barrier, which again has a plus 1 for the thread that initializes the tests, in addition to the number of tests we're running, which in this case is 4. We then go ahead and run a loop that iterates through each cycle. Each time through, we go ahead and start a new thread so that all the threads are up and running. Then we go ahead and prepare to start the tests. And these tests, of course, will run each of the different GCD algorithms. We call the await method on the entry barrier in the main thread. Now keep in mind, as we'll see in a minute, all the other threads running in the background are also going to be calling entry barrier await. And the way this works is this lets all the worker threads proceed at the same time, which fixes that limitation we talked about earlier with countdown latch, where it didn't actually have a true entry barrier that made everything start at the same time. The countdown latch worked by only making sure that the other threads in the background wouldn't start until the main thread said it was okay for them to run. But they may show up in different order and then start whenever they start, when they get there, as long as the main thread is called wait. We then call a wait on the exit barrier, which will wait for all the threads to finish in this particular cycle. And then we'll loop back around again and it'll run again for each of the cycles we're running, since this is a cyclic barrier test. Let's now go ahead and take a look at the GCDCyclicBarrierWorker class. This class applies the 2 entry and exit barrier cyclic barrier objects to coordinate the benchmarking of a given GCD algorithm implementation. And as you can see here, we define a worker that runs in a thread. We implement runnable so it can run in the thread. The constructor goes ahead and initializes the barrier fields that are passed in, plus other stuff, which we don't show here. And then the hook method, the runHook method, runs when the thread is started, and that goes ahead and calls await. So each of the background threads that are running the GCD algorithms will be calling await. And this is an entry barrier that causes all the worker threads to wait until they're ready to run, thereby fixing that earlier limitation with countdown latch we talked about before. At this point, this particular test can run the GCD algorithm that's associated with this object, which was not important as we mentioned here, because we're just focusing on the barrier synchronization logic. And then the last thing we do is we have the exit barrier wait until all the other threads are finished with their computations before returning. And when all the other threads finish, then that will, of course, allow the main thread to also return from its call to await on the exit barrier as well. So that's essentially the walkthrough of the Java CyclicBarrier example application. And it's interesting to compare and contrast that with the countdown latch version we talked about earlier.